We're going to start our discussion of propositional logic, looking at a few arguments whose logic turns on propositional logic. And let's just quickly take a look at a couple of examples. Here's an example taken out of baseball. Either the American or the National League wins. Speaking of the All-Star game, which is the All-Stars of one league play the other. Since the American League did not win, the National League did. Sounds like a good argument. Or the next one. Imagine we're trying to figure out where our friend Jones is, and we know Jones is at Kingsborough on campus. If Jones is at Kingsborough, then she's in Brooklyn. Therefore, Jones is in Brooklyn. Again, we're going to see this is a case where the argument ends up being a valid argument, a logically good argument because of propositional logic. And a final one we'll take a look at is, if Smith studies, then she passes the course. If she passes the course, she graduates. Thus, if she studies, she graduates. And let me remind you that one conclusion we've come to is that what determines whether an argument is logically a good argument is the logical form. And in this case, it's going to be the propositional or sentential, that is the logic of propositions or the logic of sentences, but the patterns of argument that are involved in propositional and or sentential logic. Now, there's a reason that this followed our discussion of truth, because remember, when we were talking about truth, we discovered that primarily the things that are true or false are propositions. And if we look at these three arguments above, we're going to see that what makes these arguments logically good arguments is that they're using relationships between different propositions. And the reason sometimes people call this sentential logic has to do with that, the branch of philosophy called metaphysics, that they have concerns about the nature of the entities. Don't worry about it. We're just going to continue talking about logic without committing ourselves to a particular metaphysics. Now, when we're looking at propositional logic, there are things that we refer to as propositional connectives, or their logical words. And remember, in the case of predicate logic, all are, some is, or some are, those were the words, the logical connectives between different predicates. That's why we called it predicate logic, or sometimes between different categories, categorical logic. In our case, there are things that connect, there are words that connect sentences, and there are several of them, and let's consider what they are. The first one is known as disjunction, which is either P or Q. One of the two of them is true, so P or Q being two propositions. You can combine them with an or to tell you that P or Q, and we know that P or Q is true just in case at least one of those propositions is true. Now, another similar kind of logical word is and, which gives us a conjunction. P, proposition P, and proposition Q. And we know that P and Q is going to be true just in case both propositions P and Q are true. Another connective, well, it's not really a connective, but it works on a proposition, is not. Sometimes expressed as that symbol is called a tilde, not P. So what makes not P true is the fact that P is not true or P is false. Then there's going to be really the final basic connection, which is sometimes, and what it's called is a conditional, or a hypothetical. Hypothetical meaning, when we talk about hypotheticals, we're talking about something that does not or has not necessarily taken place, but rather something that could. So it's expressing the relationship between two propositions. If P is true, then Q is true. Another way of saying that is P only if Q. So if P, then Q, and that one is true. Or actually, it's easier to think of there's only one case, well, where that's, well, what that tells us is that if there's a case where P is true, then that in that case proposition Q is also true. But notice, if P isn't true, all bets are off. And actually, you can use conjunction and conditional to get something known as the biconditional, which is P if and only if Q, which is the same as saying P if Q, in other words, if Q, then P, and P only if Q. The idea is it's if P then Q, going in the forward direction, and conjoined with the other proposition, if Q then P. So notice, using these logical connectives from a couple of propositions, we can create yet a third. We take two propositions, we connect them with one of these connectives, and we can get yet a third proposition whose truth or falsity is dependent on the components. And similarly, the logical form is going to, of certain inferences is going to depend on the use of these logical words.